the electron configuration for magnesium atom. We've already learned that in a neutral atom, the number of electrons are the same as the number of protons, or the number of protons are the same as the number of electrons. It is only in a charged atom that the number of protons are different from the number of electrons. So in this magnesium atom, it is a neutral atom, and as a result, the number of protons are equal to the number of electrons. So for the configuration, we are going to use 12 electrons since it is a magnesium atom and magnesium is the 12th element on the periodic table. So let's proceed to the board. Okay, so the electron configuration of the magnesium atom. So we have our magnesium. The electrons are 12. As I said, always make sure you know the number of the electrons that you are going to distribute in the various atomic orbitals of that given atom. And we've learned that the number of protons are the same as the number of electrons, only in a neutral atom. Yes, in the previous video lesson, we have all that. So if today happens to be the first time you're coming across my video, then check the links below for further information. All right, so the first orbital in question is the first shell, and according to Wongan policy, can take a maximum of 2 electrons. All right, according to Bohr, from the 1s we move to the 2x, which can also take 2 according to policy. Then we move on to the next, which is the 2p, which take a maximum of 6 because it is a subshell, have 3 subshells, each taking a maximum of 2. So 2 times 3 making 6. So 6. Now, so we have 10. So when we deduct the 10 out of the 12, it means it liberates 2 additional electrons. From the 2p, the next orbital there is the 3s, and that can also take a maximum of 2. So this is the configuration of the magnesium atom, the electron configuration of the magnesium atom. Let's see for the condensed configuration. So 1s2, 2s2, 2px, 2py, 2pz, right? So 2, 2, 2, making 6. Okay, then 3x2. Okay, let's end it with the Bohr notation or representation. So 1s, 2s, 2px, 2py, 2pz, and then 3x. So this is a subshell, another subshell. These ones are degenerate, right? We've learned that. As I said, if today is your first lesson, check from the links below, okay, for the previous lesson. Okay, so this is a Bohr notation. According to Wolfgang Paulus, each orbital can take a maximum of 2 electrons, and they must have an opposite spin. So we have one spin up, another spin down, opposite spins, clockwise and anti-clockwise, spin, another spin. Then for the degenerate orbitals, according to Hans' rule of maximum multiplicity, we first fill them singly, right? Parallel spins before we pair in the opposite direction. Okay, then the 3s take 2, so 1 2. So this is how we write the electron configuration for the magnesium atom. Any of this configuration is accepted and is correct. Okay, so before we end the lesson, I would like us to learn other vital information about the magnesium atom. So we have the magnesium atom. This is the chemical symbol, capital letter N, small letter G is the symbol for the magnesium atom. We have the atomic weight here. We have the atomic number, which is 12. And the electron configuration here, in the diagram, we use the neon core. Very soon I'll be talking about helium core, neon core, argon core. We have cores, okay? Specifically, we use the noble gases. I'll be talking about all these things. So let's move on to the other information. The name is magnesium. This is how we spell magnesium. We have the spellings also here. Then we have the acid-base property, okay? Whether it is acidic or base. So magnesium is strongly basic. Take note of that. The strongly basic. When we are talking about main groups of elements, we will tackle all these things, okay? But I just want you to have a fair idea in case you don't know. Then we have the crystal structure being hexagonal shape, okay? Hexagonal shape. Then it is one or part of the alkaline earth metal. On the periodic table, we have the alkali metals, the alkaline earth metal, we have the halogens, the inert gases, okay? And this happens to be, magnesium happens to be an alkaline earth metal. And it is solid, that is the physical state. It is solid, okay, at 25 degrees Celsius or 68 degrees Fahrenheit. So stay tuned for more video lessons.